And we're back and better than ever. We're still in 10.1, and we are now talking about the mole. If you remember the last time we were taking the notes, we were discussing this idea of the mole, how it's this astronomically large quantity that is equal to 6.022 times 10 to the 23rd anything. And so just to give you perspective on how big this number is, we said that if you had 1 mole of marbles, that would cover the Earth to a depth of 50 miles. That's huge. Also, to put this into perspective, if you had 1 mole of seconds, that would equal 4 million times the age of the Earth. And keep in mind that the age of the Earth is 4.2 billion years by current estimates. So take that 4.2 billion years and go through that 4 million times, and you would have a mole of seconds. Not a mole of years, a mole of seconds. So it's a huge number. Now, when you're dealing with a mole, just like these other terms like a dozen or a couple or a ream or whatever, you can have a full mole, you can have a partial mole, or you can have multiple moles. For example, when you're dealing with, say, cookies or donuts, you can buy 1 dozen cookies, which is going to equal, I guess we should say 1 dozen cookies. That would obviously mean that you have 12 cookies. You could also say that you could also buy 2 dozen cookies, and that would obviously equal 24 cookies. Or you could buy a half a dozen cookies or donuts or whatever, and that would equal 6. So just like you can have a full dozen, more than 1 dozen, a partial dozen, you can have the same thing with moles. You can have 1 mole, 2 moles, 100 moles, a half a mole, a quarter of a mole, whatever the case may be. All right. So let's go ahead and try some of these calculations. We're going on to the back side of the notes now. I'm scrolling down. And so let's try doing some of these conversions. We're going to go from moles to particles. So the first question is, how many particles are in, let's say, 5.0 moles of oxygen gas, which will be O2. So remember, when you're doing a unit conversion, you always write down whatever unit that you're currently in. And then you keep in mind, I usually write it all the way over on the far side of the page, what I'm looking for. So in this case, we're going with particles, or we could also say molecules of oxygen. That would be the same thing in terms of the oxygen. Now, what conversion factor are we going to go from moles to molecules or moles to individual particles? Well, remember that you have 1 mole equals 6.022 times 10 to the 23rd anythings. It can be atoms, molecules, particles, donuts, marbles, seconds, whatever it is. So you can use that conversion. Now remember, when you have 2 things that are equal to one another, you can put one on top of the other. And so in this case, we're going to want our 1 mole of oxygen on the bottom, and we're going to put our 6.022 times 10 to the 23rd molecules or particles of oxygen on top. Now, why are we going to do it that way? Well, because if you already have moles of oxygen on top, remember that your moles on top will divide out with moles of whatever on the bottom. And so you have to have the fraction this way. And so then you'll perform that calculation. You're simply going to take your 5 times 6.022 times 10 to the 23rd, and I'm getting 3.01 times 10 to the 24th. Molecules of oxygen. So there's your answer. Now don't worry about how many digits we're going to carry. That's not important right now. But that would be our answer. You have that many particles or that many molecules of oxygen in 5 moles. Now what about going the other way? How many moles are in, well, let's just say we have 4.25 times 10 to the 22nd, let's say atoms of gold, which is AU. So as we scroll down here, let's go ahead and do the same type of a conversion. We have 4.25 times 10 to the 22nd atoms of gold. And we want to go to moles of gold. Now we're going to use the same conversion that we used up above, except now we're going to flip it. We're going to put the 1 mole of gold on top, and we're going to put the 6.022 times 10 to the 23rd atoms of gold on the bottom. Now, why are we going to take the reciprocal this time? Well, because we have atoms already, and we want to cancel them out. Atoms of gold. So the atoms of gold on top divide out with atoms of gold on the bottom. The only unit that you're left with is moles of gold. You're looking for moles of gold, so you're ready to do the calculation. So you're going to take, and make sure you use the parentheses or E notation properly, 4.25 times 10 to the 22nd divided by 6.022 times 10 to the 23rd. And when you perform that calculation, I'm getting 0.071, actually 0.0706, we'll just call it that way, moles of gold. So we do not have a full mole of gold, we have a partial mole. It's 0.0706 moles of gold in that sample. So you should be able to go back and forth. Now again, the key to understanding which way you're going to use the conversion are the units. The units will tell you what type of conversion will come next, making sure that you get every unit to cancel out except for those that you want. Alright? In the next podcast, we're going to take a look at calculating the molar mass of an element and the molar mass of a compound. We'll see you next time.